just doing a couple of little checks on the sound at this stage, just to make sure everything's all good, and then we'll get underway. So yeah, feel free to ask any questions, interrupt me at any time. We depend on live interaction is what we're after. So if you're here and you're watching and you want to feel free to go, by all means, give it a crack. So I just can't get my sound going there. Why that is? What's happening here? Oh yeah, give it a crack. So I just can't get my sound. Okay, looks like we're all good there. We'll just turn down the sound here just to be sure. And I'm pretty sure we're all underway there. So let's get started. This is number 8. So I've been slowly working through examples and just a little bit of an explanation, really waiting for people to come online and maybe ask some questions or ask for some help with something, and we'll see how we go. So far haven't had a lot of success with that, but anyway, let's try. So last night I left you with a little problem, which was sketch the graph 4y plus 3x equals 20. Now, well, I mean, we could sketch that one relatively easily, but I mean, there's many ways we can do it, but I said by rearranging it into the form y equals mx plus c. So let's see what we've got there. So the first thing I would do is try and get the y's on one side and the x's on the other. So I'm going to subtract 3x from both sides. So that gives me 4y plus 3x minus 3x. And you can see how that eliminates the x's from that side, equals 20 minus 3x. So we've subtracted x from both sides. Okay, and that will give us 4y. And we want it in the form y equals mx plus c, so it'll be negative 3x plus 20. So where there's no sign in front of something, you can assume it's a plus. So you could say plus there. And then each of these little, I just call them little, they go together, they're little, I like to call them little packets, but that's not very mathematical, but they can be moved around and rearranged, and the order of them doesn't matter, provided you get the signage in there. So right, so now what we're going to do is we're going to divide both sides by 4. And I used to write both sides, but I'm just going to go divide by 4. So we'll put that in there, 4. And this is all over 4. So now we'll write that y equals negative 3x over 4 plus 5. 20 divided by 4 is 5. And there we have it in the form y equals mx. So m equals negative 3 over 4 and y equals 5. So that's the y-intercept. So what we can do is just move, maybe we're looking at sketching this graph now. So when we're sketching, we just give the minimum information. So the graph we're sketching is y equals negative 3 over 4 x plus 5. So our gradient is negative 3 over 4. So it's going to decrease from left to right or go downhill. Like that there. So yeah, right. So drag out my toolbox when x equals 0. So when x equals 0, we put 0 for x, we get y equals 5. So x is 0 all along the y-axis. So we know that our y-intercept is 5. And then we can have a look at when y equals 0, we get negative 3/4 x plus 5 equals 0. Oh, that's x. Okay. So we get negative 3/4 x. So we'll subtract 5 from both sides. And equals negative 5. Right? Negative 3/4 x equals negative 5. And I'm running out a bit of space here. Oh no, I can move that down. So what we'll do now is we can divide by negative 3 over 4. But what I think it'll be easier to explain is I'll multiply by 4 to get rid of the fraction. So that's going to give us minus 3x. All right, minus 3x equals 20, equals negative 20. Negative 20. And then we can divide through by negative 3. And if we actually go right back to the beginning, we can see that if y equals 0, we get 3x equals 20. Okay, we've got negative 3 equals, we divide through by that, we get x equals negative 20 over negative 3, which is 3 6s are 18 and 2/3 positive. Okay, so that's when y equals 0. So we get x equals 6 2/3, or 6.666 recurring in decimal terms. And there's our graph. Yeah. Okay, there's our graph that we've got there, coming down there like that. And if we just look at M, just to give that a bit of a check, we've got the rise there is 5, and the run is 6 2/3. So that would be, if we work in thirds, 5 times 3 is 15. 6 3 to 18 is 20 over 5, which is 3/4, and that's negative. So our grade's all good there, just a bit of a check there. So what I did there is just checked here, the rise is 5, well, the rise is -5 if you like, and the run is 6 2/3, so rise over run, and so we're working in thirds, so 5 is 15/3, and 6 2/3, well, 6 is 18/3 plus 2 is 20, 15 over 20, divide that by, this 5 is a factor, top and bottom by 5, 5 goes into 15, 3, and into 4. So that gives us that bit of a grade there. So yeah, there we have it. That's the graph. Y equals -3/4 x, and it's also known as 4y plus 3x equals 20. So that was the overnight one there, working with straight line graphs. So now let's have a look at something, a couple of straight line graphs, and okay, let's draw the graph here. Y equals 2x minus 3. Y equals 2x minus 3. So I'm going to draw that graph. And so we know that the intercept is here, -3. Okay. And so let's, so we know that's there. The gradient is 2. Let's just have a look and see when x equals 0, when y equals 0. Then we get 2x equals 3, and if we divide that through by 2, we get x equals 3 over 2, which is 1.5. So that's it there. That's 1.5. Okay. Now, if we were to draw another line, just say a line here, a graph. Okay. Let's just say I don't know. Let's see that graph there's got a bit of a negative gradient, 1 there. So let's say y equals -x, and plus 5. So we'll say that graph there, we'll say that's 5, and that's 5, and that's the graph y equals negative x plus 5. Okay, and the two of them, what we call intersect, interestingly. And they intersect at that point there. And so what is that point? What's happening at that point? At this point here, what is that point? Well, at that point, we know that y equals 2x minus 3. We know that because it's on that line. And we also know that y equals negative x plus 5. We know that. So therefore we can say, well, 2x minus 3 equals negative x plus 5. Because it's also on that line. And we can see there that we've got some sort of linear equation. So let's see what we can do there. If I add x to both sides, I'll get 2x plus x minus 3 equals negative x plus x, they'll cancel, it equals 5. And then if I subtract, add 3 to both sides, I'll get 3x equals 8. And so we'll get x equals, we'll divide by 3. X equals 8 over 3. So that point there, the x value, okay, the x value is 8 over 3. And so what's the y value? Well, the y value equals negative x. So then we can say, well, when x equals 8 over 3, y equals negative 8 over 3 plus 5. Okay, that's a 5 there. Plus 5, negative 8 over 3 plus 5. So 8 over 3, so that's 5. If we make 5 in thirds, that's 15 over 3. 15 over 3, or 5 is 15 over 3 minus, I'll go down here, minus 8 over 3 equals 7 over 3. So y equals 7 over 3. And that would be 7 over 3. That's what that point would be. Whoa. two straight lines, the intersection of two straight lines. So this actually has a name, this process, and it's called simultaneous equations. Simultaneous equations. In this case, there's simultaneous linear equations, which means they're straight lines. And so there's various methods for solving these. And this one that we've used here is sort of, I guess it's substitution. Sort of. So what we can do is we can have a look now. You might have noticed me hesitating a little bit there in the when I was doing that second line, because what I was trying to do is to see if I could get nice whole numbers in there rather than the fractions, and that can take a little bit of doing. You know, to actually formulate questions that give nice whole answers. And sometimes this can be a bit of a clue in exams and stuff like that, where if the answer's not a whole number, you can get a little bit suspicious, because, you know, quite often they are. And if you're getting a fractional answer or decimal, it means that maybe you've made a bit of a mistake. And this is why it's very important to do lots of practice, and, you know, be very confident in what you do. And the way to get confident is to practice, practice, practice. Right, so let's go to ChatGPT, and I'm going to ask it to, can you give me a pair of simultaneous equations in the form x plus y equals a number, where the answer or the intersection of the two equations has coordinates that are whole numbers. That is, no fractional numbers. So I would like a pair of simultaneous equations that could be solved using the elimination method. Okay, let's see what you got, Mr. ChatGPT. Okay, so now that will hopefully give us a pair of equations. Now, to do these simultaneous equations, you don't actually have to, so we've got x plus y equals 12. Here's your pair. So, okay, so we've got x plus y equals 12, and x minus y equals 4. Okay, now it says here, these are perfectly set up for elimination method. You'll find neat whole number answers at the intersection point. Yes, this is true. Okay,